Hello. Today I'm going to talk about coding. In my right hand, what I'm holding is a KitRai. Some of you might be familiar with it. In my left hand, this is a microbit. Now kids. So, when you are learning coding, if you ever need to use physical hardware boards, these two specific boards are quite popular and widely used among many enthusiastic users. For today's particular coding session, I might choose a topic that isn't very familiar or commonly known to most young kids, but that's perfectly okay. I will try my absolute best to explain it as clearly and comprehensively as possible. I genuinely want you to get much more out of learning coding, to also learn about various other interesting things, and to become thoroughly familiar with some new and important terminology. Yeah. Today, we're going to talk about the term integration. Integration means that while we're learning coding, we're also incorporating other subjects. Normally, when we learn coding, we also pick up knowledge from other areas like science, mathematics, or even the arts. That's usually the case. But today, as you might expect, we'll focus on something scientific, although the name of the topic might not be very familiar to you. The topic is remote sensing. For some adults, this term might sound familiar because about 20 years ago, it was quite a buzzword, as it was a new technology at the time. People were interested in what it was and how it worked. So today I'll explain remote sensing to you in a simple and brief way, just enough for us to understand it within a short period. To put it simply, remote sensing is the detection of something, anything, without physical contact. In this context, it means detecting things without physically touching them, gathering information without having to make contact. That should give you a clearer picture. If you still can't think of an example of collecting data without touching, let me suggest something close to home, right in front of you right now, a camera. With a camera, we collect information, right? That is, the camera captures an image, and the main sensor receives the image. Then it gets stored in the camera's memory. In the past, it would be stored on film, but nowadays, hardly anyone uses film anymore. So you can see that when I talk about collecting data without physical contact, it means capturing an image and storing it in the camera. This is what remote sensing really is. Many people might say, wait, isn't it only about satellites or things in outer space? That's not the case. Remote sensing covers everything, anything we can detect without having to touch it. I'll give you this simple definition: detecting without touching. Now, remote sensing can be divided into two groups. Just remember this for now, kids. There is active and passive. Just now I mentioned cameras. If we pay close attention to cameras, we can see where they get their light from. It's called receiving light from the sun, right? We're not shining any light ourselves. I'm not talking about cameras that need a flash. I'm referring to when we use cameras outdoors. That's what we call passive remote sensing. So, what about the active type? Active means it's similar to at night when we send out infrared light to hit something, and the image that reflects back to the camera, that's what we call active. Notice that if we use sunlight, we're not the ones emitting the light. The sun is already bright. But if it's active, we have hardware that emits infrared light to the object, and the reflection comes back to the camera like this. We consider that active. You can see that these two are only different in this way, active and passive. I want you to know this as background knowledge. Now, how does this relate to us? We're going to write code for both the microbit and KitRai boards to experiment with two projects. The first project is passive and the other one is active. These are the projects I mentioned earlier. I've already done them and have examples ready. That's why I want to share them, so you all can try them out in your free time. It's something that's totally doable and not difficult at all, and you'll also gain knowledge about remote sensing along the way. Let me summarize remote sensing again. For the passive type, we don't need to send out any light or signals. We use sunlight and collect the data. There are other examples as well, such as thermal cameras. For instance, when we take thermal images of a volcano, that's considered passive because we aren't sending any radiation or light to the volcano. But we have thermal cameras that detect temperature, and they can show the temperature differences in various areas of the volcano. Even residential houses will appear in the image, showing which areas have higher or lower temperatures and by how much. This is also passive, not active. Now, examples of active remote sensing that we are familiar with, especially adults, are as follows. Resource exploration using satellites might seem distant from our daily lives because satellites are used. The satellite will be positioned to send waves down to the target area, and then the part that is reflected back is measured. With this method, the frequency range used could be radiation in various bands or light in the ultraviolet or infrared range. This can reflect images for us to further analyze, such as determining whether an area has saline soil, or if corn is being grown there, or even identifying where crop pests are present. All of this can be analyzed from satellite images. However, these are not images captured with visible light, but rather by emitting different frequency bands and analyzing the reflected signals. This refers to what we've just discussed. I think it's clear now whether this is active or passive. It's active because it emits waves down and then receives the reflected signals. You'll see that most of the time satellites are used for this, or sometimes airplanes. Even in the lower atmosphere, it's all considered remote sensing. Even if we don't shine any light down and just use sunlight to capture images, that's also remote sensing. Now, I'll move on to the next topic. How does remote sensing relate to what we've discussed? Allow me to go back a bit. I need to ask, when we're outdoors and we see a red rose, how is it that we perceive the rose as red? What process occurs that allows us to see the rose as red? Many of you probably know, if you've studied light, that sunlight contains a spectrum of 7 colors, right? When sunlight shines on the rose absorbs all the other colors and only reflects the red. That's why we see the petals as red. The same goes for green leaves. When sunlight with its 7 bands shines on green leaves, the leaves absorb all the other colors and only reflect green. Our nerves then perceive the leaves as green. From this concept, I'll now start talking about microwaves. You'll notice that microwaves there are 3 dust particles. For those of you who are familiar with grade 6 or grade 9, now for the 3 Buddhist points. The teacher connects the first and second Buddhist points to 2 LEDs, one to the blue LED and one to the green LED. Some LEDs are connected to 2 colors. As for the output at P0, remember P0 is connected to something from the area. Area stands for light-dependent resistor. A light-dependent resistor is a component that it basically acts as a resistor, which we call a resistor, and it's a type of resistor whose resistance value changes depending on the amount of light that hits it. So, to give you a clearer picture, when there's a lot of light, the resistance decreases. When there's less light, the resistance increases. That's why we connect the LDR to the circuit so that there is a voltage drop across it on this side. Therefore, whether more or less light shines on it, we write code to have it record the value accordingly, which is a numerical value, right? The value that is input and stored is a number, which depends on the amount of light that hits it at any given moment. Now, coming back to our 2 LEDs, the green and the blue, I will start the experiment by using a yellow ping pong ball. I'll place the yellow ping pong ball close to both LEDs, which are right next to each other. But I'll turn on one LED at a time, and the LDR will also be positioned nearby, so that the LDR is in a spot where it can receive the reflected light. On the air side, when we shine light from the LED onto the ball, the light reflects back to the LDR. I hope you understand. I might show you a clearer picture later. So I wrote code to turn on each LED one at a time. For the blue LED, we measure how much light the LDR receives and store that value in memory. Then we try the green LED. When the green LED is on, the reflected green light will bounce off the yellow ping pong ball, right? And then we measure how much of that light hits the LDR and store that value as well. You'll find that if you compare these 2 values, the numbers remain constant. If we pick another yellow ping pong ball and do the same thing, the results will be very similar. Now you can see that, right? But if we use the red LED, will we get the same result? Probably not, because red light reflects differently and green light reflects differently too. So we likely won't get the same values. So we try with other colors as well. Try pink, try blue, try random colors, and record the results. At this point, it might get a bit tedious, but we record all the values that the LDR displays on the screen and note them down. Then try taking another ping pong ball of the same color, another pink one, and place it in the same position. You'll find that the values aren't exactly the same, but they're close. Now, let's use our coding knowledge to write a program that displays on the screen which color ping pong ball is currently placed. If we put a red ball, it should display an R. If we put a green ball, it should display a G, and so on. So you can see that now we've managed to do remote sensing, right? The system can now detect which color ping pong ball is placed on the LDR. See, that's what it can do. From here, you can start thinking about building a sorting machine, for example. Like what I did. I just made a demonstration set, not a real sorting machine. But since we already have ping pong balls of different colors, and I wanted to show this to the kids, I used ping pong balls and had the machine sort them based on the color I put in, one at a time. And if a pink ping pong ball passes by, it should drop into this slot. If a red one passes, it should go into another slot. Or if a yellow one passes, it should go into yet another slot, something like that. I think this kind of project is interesting and could be fun to try out. If anyone has any questions about the details, feel free to ask. Anyway, in this video, when I edit it, I'll also add text information on the screen. Earlier, I was holding two pieces, right? Don't worry, I'll explain as we go along. Because KidBrite already has an LDR built in at the top, right? So everything I just mentioned that we did with the microbit, we can do the same way with KidBrite. Plus, we don't even need to find an external LDR, right? It already has two outputs, so we can connect one output to the red LED, another output to the green LED, and another to the blue LED. And the LDR we'll use is this one. So that's how it works with KidBrite. We can also do haptic remote sensing just by writing code, and even if we connect everything together, you can see that it doesn't use up much, doesn't consume many resources at all, but we'll gain knowledge about how color sorting works, or the effects I mentioned, how they actually do remote sensing in practice. Now, if we've reached this point, have we skipped anything? Yes, we've skipped the passive part of remote sensing, so with this one, let's do remote. Can we do something passive? Speaking of microbit, yes we can. I already have an example. We already know that out of the 25 LEDs, there are 9 LEDs here that can also detect the amount of light falling on them. That is, they use the properties of the LED as a photodiode as well. So, when light falls on them, we can program it to read a numerical value indicating how much light there is at that moment. Therefore, from here, we can write code to use the normal light level in the room as a baseline. For example, right now in this room, the light level is set as normal. If we block the light with our hand, or if the amount of light falling on the sensor decreases, we can have it activate, like triggering a switch or something. In the example I wrote, I had it press a hand sanitizer bottle, because the idea is to avoid touching or bringing your hand too close to the screen. The sanitizer bottle acts as a switch, so you just put your hand underneath. It could be used by millions of hands. This is just one example. You can think of other ideas as well, as I mentioned. For instance, you could have an LDR, light-dependent resistor here, and then write code for it to detect the ambient light in the area. There's no need to shine a light directly on it, because wherever we are, there is always some light, whether indoors or outdoors. So, have it remember the light level in that area, and whenever you block it with your hand, even just a little, the amount of light it receives decreases, and it triggers the switch. So, both examples I just mentioned. Micro.bit, right? You see now that we're acting as a remote sensor, but it's passive because we don't need to shine any light onto it, correct? We're using ambient light from the environment. This is one mode of setting, collecting data without any physical contact. You can probably picture how we integrate coding with remote sensing. I hope this helps you understand the concept. If you have any questions, feel free to write and ask. If you're still having trouble or want more details about anything, I'm more than happy to help. Thank you.